Hello, 8.6, solving trig equations. You're going to need a lined piece of paper, a unit circle, and a calculator just at the beginning, and the page of notes. So pause and get yourself set up, and here we go. We just have a bunch of examples. So our goal, you ready? Our goal is to find theta. So the goal is find theta. Now what is theta? Theta is an angle in radians. So in math from now on you're going to be using radians, but in science classes you switch from radians to degrees and radians, and you need to be able to go back and forth. But pretty much in math we're in radians. So to start, okay, example 1. So this little piece of paper will be 8.6 examples. Here we go. Example 1, the sine of theta. Here's the thing, you've already done this. That's why I'm letting you know. Now, is this number on the unit circle? Nope. So if it's not on the unit circle, then you use the calculator to find it. So how do we get theta by itself here? Well, theta equals what? We have to move this, right? How do you move the sine to the other side? You do inverse sine. Sine to the -1 of this number. And since that's not on the unit circle, we're going to use a calculator. But careful, because the calculator, do you see how it's in degree? DEG. So you need to, let's see, can you guys see this okay? Press this button here, and it changes from degree to radian. I guess you have to press to the right and press enter. And here we go. So we're going to do inverse sine of 0.523. And the angle, I'm like, that doesn't look like a nice angle, but it's in radian, so that's okay. There we go, that's number 1. Isolate the variable by doing inverse trig function. Number 2, however, doesn't have just a theta. It says tangent of 2 theta equals -0.1258. Okay, but still we need to move this tangent to the other side. But instead of theta being by itself, what's left over here on the left-hand side? We have 2 theta equals inverse tan of -1 point. So let's use a calculator to find this. So we're going to go second tan -1.258, and we get this lovely number. Now, did we solve for theta? No, because it says 2 theta. Well, what do we need to do to get theta by itself? Just divide by 2. So sometimes you're going to have operations or steps inside the parentheses here after you move the trig function to the other side. So theta equals, my answer's here already, so I'm going to just put divide by 2 equals -0.44. Oh, this is a silly one to round, so I don't want to round. I'm just going to write them all out. Okay, that's number 2. All right, steps to solving trig equations. So step number 1. Isolate trig function. So get the trig function all by itself, just one trig function. And then do inverse trig. And we may need to add to this instruction box. And then isolate variable. That's kind of the steps. All right, no more calculator. Number 3 and 4 are solving equations with sine and cosine. So I'm going to write down number 3 on my lined paper. Now, do you guys see how there's 2 trig functions? We cannot have 2 trig functions. It needs to be 1 trig function. So what can we do to turn this into 1 trig function? Didn't we just solve something with tangent? And isn't tangent sine over cosine, right? So look at this sine and this cosine. Could we divide by cosine here? What is sine over cosine? Sine over cosine is tangent. Now, no more calculator. These were decimals. Those are from the calculator. This is not. This is on the unit circle. So we isolated the trig function, and now we're doing inverse trig. You know how I wrote -1? You can also write arctan. All right. What I've been told is that arctan couldn't fit on the little button of the calculator, so they just made up tan to the -1. That's what someone told me. I don't know if that's true. So theta will equal the arc whose tangent is √3. This is where you go through your unit circle. Where is tangent? Where? That's your theta. At what angle? At what angle? Where? Where in radians is your tangent √3? Now remember, tangent is y over x. So if I do 1 over the √3, would that be √3? No. If I do √3 over 1, is that √3? Yeah. So we have it's positive, right? So we have the tangent of pi over 3 is √3, pi over 3. And then there's another place where we have the negative. Oh, you guys know sometimes, a lot of times, most of the time, you can, if this is one of your answers, you just go across here, and then 4 pi over 3 is the other answer for tangent. 4 pi over 3. There we go. We just solved a trig function, a trig equation. You ready for another one? We're going to do as many examples as we can in the 15 minutes. That was 3. So after the number 3 comes 4, and we have 4 sine equals cosecant. My brain's a little so today, so I'm going to change cosecant to 1 over sine, like that. Is that right? Okay. If I wanted to move this sine to the other side, I would divide it, but I can move this to this side and multiply it, and I'll have a sine squared. Let's see. 4 times sine squared equals 1. You with me? What's our next move? We need to get sine by itself. Oh my gosh, I'm excited. Okay, let's get sine by itself. So what do we do with the 4? We can divide by 4, right? Now we have sine squared theta equals 1/4. But what do our notes say? Our notes say, step 1, isolate the trig function. Is the trig function by itself? Nope, it's not. It has a square there. How do you undo that square? That is right, class. You could take the square root. And if you take the square root of that side, take the square root of this side. And you know what's cool? The square root of 1/4 is what? 1/2. And that's on the unit circle. Isn't that neat? Let's go back. What did we do with the cosecant? We turned it into 1 over sine. The signs need to be on the same side of the equal sign, so I multiplied both sides by sine theta. Sine times sine we write as sine squared. Then I moved the 4 to the other side by division here, and then we can take the square root, and where, now we have to answer, now that this is by itself, we're going to say theta equals arc sine of 1/2, and that means where on the unit circle is the sine or the y value 1/2. And I'm wondering, are we supposed to be looking at -1/2 also? Remember when we take a square root, positive and negative? We're going to have to check our answers. So where is sine equal to 1/2? We're at pi over 6. Where else? 5 pi over 6. And we're wondering if we should include where it equals -1/2. Are we including these? And this. The only thing we could do is plug it in to see what works. So the sine at 7 pi over 6, well, what was that again? It was -1/2. So if we put a -1/2 here, we would have -2. And if we put 1 over -1/2, we would also have -2. So guess what? That does work. So the positive works and the negative works. So change this question mark to a yay. So both positive plus or minus worked on that one. We're out of room. Arc sine of the negative. So we just plug them in to check and it works out. Good. All right. Where are we next? Oh my gosh, we get to factor. Oh, okay. We can do this on the paper because we're not solving anything. Ready? Completely factor each of the following trigonometric expressions. Okay, you ready? Pretend this was 4x squared minus 1. If you had 4x squared minus 1, that's a difference of 2 squares. How would that factor? 2x plus 1 and 2x minus 1? But it's not an x, it's a sine. So we get to factor this. Wherever you put an x, we're just going to put a sine. So it's going to be 2 sine theta plus 1 times 2 sine theta minus 1. See how we factor that? This is a difference of 2 squares also. So just like x squared minus y squared. So we're going to have sine plus cosine times sine minus cosine. Who made this worksheet? Okay. Oh, I said use lined paper, but it's okay. I think there's enough room here. All right. This is not a difference of 2 squares right now, but what do you notice? Tell me what you notice. What do you notice here and what do you notice here? Is there a common factor? Yep. So we're going to, what's a common factor? Cosine. Okay, watch. When we factor the cosine out, watch what happens. So we took out the common factor, the cosine, and now what do we have? A difference of 2 squares. So get your eraser, because I need this space right here. 2 minutes. Oh, there go my lights. Did it adjust? Let's see. Oh, you're just watching a blue screen now. It's blue, but I'm wasting time, and I'm almost out of time. Sine squared minus 4 cosine squared. So that's going to be sine plus 2 cosine times sine minus 2 cosine. This is why we learned factoring, you guys, in order to factor this. Isn't that cool? Don't ask me why we're learning this, but that's why we learned factoring. Okay, now this is like x squared minus 2x minus 15. X squared minus 2x minus 15. How would this factor? What multiplies to get -15, but adds to get -2? Like that, 3 and 5. So we're going to do the same thing, but instead of x, we're going to use sine. So we have sine minus 5 times sine plus 3. Cool? Oh, I'm out of time on the hardest one. This is a guess and check because it has that 4, but I'm not, let me see, we know it's 3 and 1, and I definitely want to get to this one. Do you see how that's cosine to the 4th power? So instead of doing cosine cosine, it's going to be cosine squared, and that's a 1. Okay, out of time. I didn't get to factor this one. This is either 4 and 1 or 2 and 2. Let's see, 2, 6, I think it's 4 and 1, you guys.